In this problem, we have two currents, I1 3 amperes and I2 5 amperes, both pointing out of the board. So both of the currents are flowing out of the board. They are separated by a distance d, which is 20 centimeters, and the question is, what is the magnetic field strength and direction midway between the two wires? Well, let's first find out what is the direction of the magnetic field created at this point due to the first current and then due to the second current. Just the direction. The current is pointing out of the board, so using the right hand rule, we can see that the magnetic field lines are going counterclockwise. So I draw a circle of that radius, and I know that the magnetic field is going counterclockwise. So here the magnetic field is pointing straight up, perpendicular to the radius, and that's B1. The same thing is true for the second current. The current is pointing out of the board. Using the right hand rule, I can see that the current will also go counterclockwise. But here at this point, if you draw a circle, this blue one, the magnetic field will be pointing straight down. So this would be B2. So again, current is pointing out of the board, magnetic field is going counterclockwise, so at this point it's pointing straight down. So the magnetic field at the center, the resultant magnetic field, will be the difference between the two. So all we need to know now, what is the magnitude of B1 and B2 and which one is bigger. So let's calculate for B1. B1 is equal to mu 0 I1 over 2 pi, and now we need to know the distance. The distance is half of that d, so we can say d over 2. Well, we can now substitute for the numbers. 4 pi times 10 to minus 7, that's mu. Tesla times meter over ampere. I1 is 3 amperes divided by 2 cancels 2, so you have only pi times d, which is 20 centimeters, so 20 times 10 to minus 2 meters. So this is going to give us 6 times 10 to minus 6 Tesla, or we can simplify that and say that this is 6 microtesla. Now let's do the same thing for B2. B2 is then equal to mu 0 I2 2 pi d over 2. So exactly the same thing, with the only exception that we have I2. So B2 is then equal to 10 microtesla. Well, because current I2 is bigger than I1, so B2 is bigger than B1. Which means that the resultant, B total, would be the difference of this. So that's 10 microtesla minus 6 microtesla. And so the answer is 4 microtesla. And the direction of the total magnetic field will be the same as the direction of B2. So the total will be pointing, well, at this point, but pointing down, and is equal to 4 microtesla. Now, without calculations, let's just think about what will be the direction of the magnetic field somewhere here, the total magnetic field. Well, let's look at B1 first. Using the right hand rule, we know that B1 at this point will be pointing down. B2 at that point will also be pointing down. You will have to draw a much larger circle like that, and the orientation of the magnetic field will be also counterclockwise. So here the magnetic field will also be pointing down. But B2 is going to be smaller in magnitude because it's further away. So which means that the resultant, B total, will be pointing downwards. Try to think what's going to be the direction and the magnitude of the magnetic field at this point.